James Bond was right, and he already did the test long time ago. There is a difference between shaking and stirring.
I would like to treat water the same way I treat a beautiful woman. The Egyptians had no idea what radioactivity was either. That's our state of knowledge. Perhaps in 10 years we'll understand what it's all about. This statement that water has a memory, of course, that practically changes our whole way of looking at the world. Water is a bearer of secrets. It's full of mystery.
It is always helpful when it comes to creating and preserving organic life.
It stubbornly resists when we try to make it obey the established laws of physics, and then it lets the secret out, but poses 100 new mysteries.
To physicists, water is abnormal. While other materials contract as they cool, water expands when it freezes, making it lighter so that it floats on the surface of liquid water. If it sank to the bottom instead, life could not exist down there. The oceans would be one giant iceberg.
4.5 billion years ago, the conditions on the surface on Earth were very, very hostile. We don't know how it happened, however, we do know that it happened in what is called the primordial soup. This was a soup in quotation that was made from water and a mixture of many different molecules. The first organism that appeared were the bacteria. Nobody knows, and this is one of the greatest mysteries of science, how life evolved from the inanimate matter.
The response to this unanswered question is most likely to be found in water. That's where we must begin our search for the origin of the first living creature. Can the water of today tell us something about the beginning of life? How the first organisms emerged from the sea remains another mystery.
The Institute for Statics and Dynamics of Aerospace Structures at Stuttgart University. Professor Bernd Kröplin is a recognized and successful scientist in the aerospace field. Together with his colleague, Regina Henschel, he's been exploring the question, can water pick up and store information? This investigation could shake the foundations of traditional physics.
The
statement that water has a memory practically changes our whole way of looking at the world, of course. Let's travel down the Rhine in the figurative sense. The water is flowing down the Rhine, picking up information everywhere it goes. So the water has more information at the mouth of the Rhine than it had at the source. And the Dutch, living at the mouth, when they drink that water, they're also drinking all that information. Thus, the world's oceans would no longer be something that separates us, but instead a giant storehouse of information, and the rain would perhaps be a data medium carrying information to the world.
A great notion. But what kind of information is this? Can we make it visible, or even measure it? In order for experimental results to be considered valid, they have to be repeatable. But how can we look inside a drop of water?
The Aerospace Institute in Stuttgart has discovered a relatively simple way of making the structure of a drop of water visible. The drops are placed on a sheet of glass and allowed to dry. Under the microscope, they reveal fascinating images that can be photographed with a special camera. The researchers have had their efforts rewarded by insights into a very beautiful world. Each drop has a face of its own, unmistakable and unique. Why are the individual drops so different from one another? What do the photographs tell us? Who can interpret them? What information is stored in them, and where did it come from? Perhaps from humankind itself? Here we have person A who does something, and person B who does something, and person C who does something. They've all placed drops on a slide. They were from the same water, and now they've all dried. And each of these three drops looks different. We didn't change anything ourselves, and yet we get three different images. Thus, the differences must come from the three persons. And that, of course, made us want to find out how it could be possible, or better yet, whether it could be possible. So we got a lot of people to come to a lecture hall here at the Institute, gave them all the same water, had them make drops at exactly the same time, collected all the drops, and then discovered that each individual produced different images from the same water. And here you can see the results. Here on the right you can see that the images of the individual students are different, but those made by a given student are all quite similar. This is the work of the first experimenter, this one here from the second, this from the third, and this from the fourth. Individually they can quite easily be reproduced, but you would never have thought that they were all from the same water, because when you compare the images from the different people, you see some big differences. So it must be the case that information from the experimenter, who was holding the syringe in his hand but never touched the water, must have been transferred to the water and was captured in this image.
Researchers around the world have been persistently trying to get water to reveal its secrets. Often it takes an accident to lead to a surprising result. Those who thought they knew everything about water have had to admit how little they really knew about this element. A sensational report arrived from America.
Water was not originally the subject of research by the American TV technician John Cancius from Pennsylvania. He was looking for a way to fight cancer cells in the human body. One night he had the idea of injecting gold nanoparticles and then exposing them to radio frequencies. The radio waves are said to heat the diseased cells and kill them without harming the healthy ones. By chance, he also discovered that radio frequencies can split salt water into oxygen and hydrogen, thus providing a source of fuel.
The interesting thing is that's probably around 1500 degrees centigrade. This is the most abundant element in the world, water, and salt water is everywhere. And to see it burn actually gives me chills.
No one has yet explained this phenomenon, but it is clear that the strong flame it produces can, for example, power a Stirling engine. The renowned physicist Rustam Roy had this to say about the discovery.
It is the biggest discovery in water research in 100 years. That's John Barker.
In 100 years?
In water research.
In fact, there is no guarantee that every discovery will contribute to human progress. Not without reason does it make an inventor shudder to realize that radio waves can make seawater burn. The idea that the black gold of oil might be replaced by the white gold of water to power the Earth's tens of millions of cars has something frightful about it as well.
The blessing and curse of an invention often lies side by side. On the one hand, it is fascinating that seawater might one day provide the solution to one of humankind's biggest existential problems, that of energy. On the other hand, we must realize that mass combustion of salt water might also have dramatic effects on the ecological balance of our planet.
Research continues, of course, even when no immediate benefit is expected. At the University of Technology in Graz, Austria, young scientists are seeking to discover why water placed in 2 glasses and subjected to a high voltage charge will climb the sides of the glasses to meet. It doesn't do it at some random part of the glasses, but at exactly the spot where the water from the 2 glasses will meet. If one moves the glasses away from each other, the water creates a hanging bridge that can be up to 2 centimeters long. So far, even the world's greatest scientists have been unable to explain the phenomenon. So far, there is not even a theory about the sensational behavior of the water.
An exact microscopic theory and an exact understanding of what is happening here, we haven't found that yet. And that is the reason that we're continuing to work on it. It's what makes this all so interesting. We would expect electrolysis, but under no circumstances would we expect a stable bridge that acts the way we see it acting here. That's what makes this all so fascinating. A half hour later, the bridge fatigues and collapses. Through the use of a red and a blue color filter, the movement of the bridge becomes more visible. It is the apparent flickering that amazes the scientists. From a physical point of view, it should not be taking place in this form because water cannot be compressed. Here we're using the same kind of measuring technique that we use in mechanical engineering, anytime that we're dealing with very high speeds in a machine, whether it's rotational speed or flow velocity. It requires a special measurement technology, which we're using here on the water bridge.
One can see that blue is trying to get to the red side and red to the blue side. The next step in examining the phenomenon more closely is the use of a thermal imaging camera. With its help, we can see more clearly the mysterious processes taking place within the bridge. It is not difficult to see that all hell's let loose here.
The problem with such measurements is always that every measurement poses new questions instead of providing new answers. That means that we are constantly observing dynamic effects, and they raise questions that we cannot answer. So we have to consider new measurement processes that would allow us to find out, for example, where the structures that we observe in this water bridge come from.
For the layman, it looks as though water could breathe. But for the scientist, it continues to be an unexplained phenomenon for now.
Since we're using pure water and have verified that that's the case, we can't be seeing foreign bodies here. They can't be gas bubbles either. It's water in any case, but it is different water. Water that has a different structure at a different density.
Despite all the problems that water poses to science, one thing is certain: its beauty is a great pleasure to behold. Scientists in Israel are also experimenting with water's ability to retain information. Here the measuring instruments are bacteria.
If you expose water to weak electromagnetic radiation, the effect should be erased within milliseconds. Not only that, but even if there is some effect, it should be so weak that even our best and most advanced technological tools will not be able to detect the differences. But the bacteria can do it. Not only they can detect the differences, but what they can do, they can amplify it to the point that we can look at the colony, that it's going after the bacteria were exposed to water that had some weak electromagnetic radiation, that they can go 2 or 3 times faster than the other bacteria.
Researchers at the School of Physics and Astronomy at Tel Aviv University are exploring the question of whether water can tell when it is subjected to weak electromagnetic radiation.
Use the bacteria as our detector to tell us or to show that really some changes have been occurring in the water, and these changes actually, we expose the bacteria after some time, an hour, 2 hours we can, that these changes that were induced could survive for a long time.
The experiments have led to interesting results.
We have preliminary results, they are not published yet, and it seems, it's preliminary results, it seems that there are many genes that are related to metabolism, related to development of the bacteria that are upregulated. So they really sense something in the water.
The internal structure of water molecules remains a mystery. Science attempts to penetrate the interior of the molecules, to study them, and to get a systematic picture of them. But even the most modern computers have their limits.
We really don't know exactly everything what happened there, but I can tell you for sure that if a molecule entered to water, so a lot of things changed. First of all, the molecule. The second, around the molecule you have a shell that we call it solvation shell of water molecule that surround this molecule and making the molecule different from the molecule outside water. So molecules can behave differently in water. And it's very interesting. Now, this molecule that you enter to the water will change all the molecule around that was before in the water. So it's a lot of complicated things. If water will be in a magnetic field, so they will behave differently. Sometimes totally differently, because in magnetic field, all the paramagnetic species, it means the species that can change their behavior according to magnetic field that are in the water will behave differently, and they will change the chemistry in water. So it's very interesting to understand that water can change according to their area, to the area that surround them.
We got like 13 different types of water, and each one of them was analyzed with the LCMS technique, and we could see great picture because the different types of water gave us a really different picture of the inside of the water, the compounds that were inside, many organic compounds mainly. But it's the first time we got a picture where we could see with our eyes that different sources are giving us different types of water, different ion matrices inside the water.
There is much to be discovered about water in the great outdoors as well. But to do that, one has to have the gift of seeing rivers and streams as partners. An Austrian river engineer has found a unique way of doing this.
Wenn man in den Fluss oder Bach oder Bächlein hineinhört,
when you listen closely to a river or brook or stream, you immediately recognize its character. It's quite simple. If the stream is loud, I know I'm dealing with an energetic stream. If it's quiet, I'm dealing with a more gentle body of water. And thus, there is a very important distinction that I can make. I want my intervention in nature to be as small as possible. That means I go to the water, And as a river engineer, I invite it to stay with me and do something for me, instead of the other way around, where I do something with the water.
Etwas zu machen und nicht umgekehrt, ich mit dem Wasser etwas mache.
The normal concept for regulating streams consists of forcing them into a corset of concrete. But when the water is high, that method often does not work. But if one gives the stream a chance to move in the shape of a spiral, it will remain on its normal course.
We've used river engineering methods to show that the current thread can be directed from the outside to the inside, and even into the stream bed.